For Unit 11, Lesson 2, Conditional Probability.
The learning targets for this are going to be calculating probability with Venn diagrams and matching probabilities from Venn diagrams. We're also going to start to see what's called conditional probability. So that's the probability of A given B, and we're going to see how do we calculate a probability given a restriction or a condition that's already happened. In these examples, you're going to see they're going to look a little different than the previous section. The previous section we were listing different values or elements that fell within an event. Now we're going to kind of switch it up a bit and look at data collected from different scenarios, and the values that are in there are representing the quantities from those different categories that we created with that data. So for example, this example 1 says students in 6th hour lunch were polled on if they have a job or play a sport, and there's a Venn diagram that's being created for that. So just to kind of identify what these values actually mean, they're identifying that event A right here. Event A is defined as students having a job. And so what that means is there's 100 students who have a job. There's 75 students who have a job but also fall within the condition of event B, which is being in a sport as well. So anything within that yellow circle is going to represent someone who identified as having a job. In the green circle I created, that's event B. So what that means is you have 200 students who identified as being in a sport, and then 75 students also identified as being in a sport, but they kind of fell within both categories. So they identify as having a job as well as being involved in a sport. One thing that's also a little different is we have this idea of 25, this 25 that's just kind of hanging out here. And so what that means is there's 25 people that were involved in like the poll that's falling within the scenario, but they didn't identify as falling within either category. So they didn't have a job, they didn't have a sport, maybe there's something else. If there was something a third. So a lot of times when there's a rectangle that falls outside of this Venn diagram and there's a value, what that means is there's a quantity that we need to represent that didn't fall within either event or category we set up. Okay. The rest of it is very similar to what we saw in the previous you saw in the previous video. So we have we always like to identify the number that's involved in our sample or our sample size. So we're going to go ahead and add that up. So we have 100, 75, 200, 25. If I was to go ahead and add all four of these values up, we would get 400. So what that means is there are 400 students that are represented in this data. The first question says, what is the probability that a student has a job? So again, a job, that's our event. That's our event A. That's right here. And so that would be 175 because you put the 100 and the 75 together. So there's 175 students who identify as having a job because I added the 100 and the 75 out of 400. And then when I divide that, that would be my probability of 0.438. So probability is calculated the same way that we saw in the previous video. For the probability that a student has a job or plays a sport, again, this is really, so this first one was looking at the probability of A, essentially. The second one is looking at the probability of A or B. Or it's really like saying the union, right? It can fall into A or B. So we know we're taking this out of 400 because that's out of the entire amount. And we're looking at the number of students that fell within either circle. So they fell within the 100, the 75, and the 200. So if we add these three values up, or a lot of other ways that you can kind of get to this value, it would end up adding up to 375. And if I divided it out, we would get 0.938. Right, so basically what that means is 93.8% of the students had a job or were in a sport. Okay, so if I wanted to turn into a percent, you just multiply by 100. The part C says that what is the probability that a student has a job and plays a sport? So this is basically like writing the intersection, right? So what's the probability of A and the intersection of B, right? So that's looking at what's the probability that it falls within both of those circles, and that would simply just be this 75 right here. So we would write 75 over 400 and then divide it out. So that would be 0.188 or 18.8%. The last two, part D and E, again, using the same data, right? So we still have N is 400. And it starts to get a little bit trickier here. So this next one says, what is the probability a student has a job given they play a sport, right? So what's happening is it's creating a condition, right? So we're looking at, of the students who play sports, how many of them have a job? And what's the probability that a student who plays a sport also has a job? So this is the same if I knew that this was event A and event B. This is the probability of what is the probability that a student has a job given they are also in a sport, right? So the condition is they have to be in a sport first. And usually like there's kind of keywords in here like the given that. So lots of different ways that you can kind of calculate this out. Probably the easiest way to probably do it is we're going to look at, well, of the students who play a sport, well, let's see how many kids are actually in that pool. So the total possible we're taking out of not 400, but of the students who play a sport. So that'd be 75 and 270 and 200. So we get 275. And of these kids who play a sport, how many of them have a job? And 75 have a job. And so if I do 75 over 275, I get 0.273 or 27.3%. Okay? So again, the condition here is we're taking it out of the number of kids who play a sport because they need to have that condition that's in there. For part E, it's same thing. It says what's the probability a student does not have a job? So it's kind of, again, switching it up a little bit. So the probability a job was event A. So it's like the probability of not A. I'm going to put a little bar on top. Notice though there's no other condition, right? So it's not saying given that or if that or anything like that. So we're still taking it out of the full amount, unlike the previous one that had some sort of condition. We're just looking out of these entire 400 kids, how many do not have a job? So when we talk about not having a job, we can do this a couple different ways, but basically we're not counting anything that falls within having a job. So we're like using the 200, but this time we're also using that 25. So there's 25 people that don't have a job as well. So when we add that up, we get 225. And that would be 0.563 or 56.3%. And that would be it.
Example, you're given a event diagram that shows a quantity for each event, so event A and event B, and given a list of statements, and you have to determine which of these statements is true. So this is an example of a matching. we'll do the first one in the notes, and then the remaining ones you're going to approach the same way and use the U-tries with the same statements. So it says match each Venn diagram with a true probability statement. So if we look at this, these are our statements. We're going to see which one of these statements will match with question number 1. So the first thing we see on here is the sample size. So the sample size for this, if we were to add all these up, we have a 3, we have a 5, we have a 2, we have a 1. So if I was to add all of these up, our sample size for this is actually going to add up to 11. So we know that the first one isn't going to go with number 1. We then see, well, what's the probability of the intersection for A and B? So that's the probability of what they share in common, which is 5, over the sample size, which is 11. And if I do 5 divided by 11, I'm going to get 0.45. Or 45%, which doesn't match that 0.3, so B isn't going to match with it either. I then see I'm going to look at the union, so A union B. So it's always over the sample size, which is 11. And I'm going to look at if I do 3 plus 5 plus 2, that's going to give me 10. So that would be the union, so 10 over 11, that would give me 0.91 or 91%. That one also does not match, so that's going to go with a different option below. The next one I see is what is the probability of A given B? So that means instead of taking it out of my sample size of 11, I'm going to look at how many exist in event B. That's going to be out of 7. And then my intersection of that is 5. So I'm going to do 5 over 7. And if I calculate that probability, I'm going to get 0.71, which is actually going to match D. If I did want to try B given A, I won't have to because I already got option D. But just remember that for that one, you would take the denominator wouldn't be 11. It would be, in this case, the number that are in event A, which is 8. And so we don't have to calculate that one, but if we did, we would have gotten 0.63. So you would have seen that your solution would have been D for number 1. For the remaining problems for Venn diagram, or 4 Venn diagrams, you can calculate the same thing, and they're going to either match with A, B, C, or E. If you have any questions, please make sure you ask them during T-Bowl time, during class, or you can come to the center. And remember, you do need to complete the U-Try problems to receive full points for the notes.